Hi, we're talking about deserts today. And so we'll be discussing chapter 13. So here I'm sharing my screen, chapter 13. So deserts are any regions with low precipitation. So that's either rainfall or snow. We mean less than 10 inches of rainfall or its equivalent per year. Now, an odd thing about a desert is that even though it doesn't get much rain, when it does, it tends to happen all at once. And so flash floods are still the main agent of erosion in a desert. If you're ever trapped in a narrow canyon, you need to be really aware of the changes in the weather, because if it starts to rain, you could end up drowning because of flash flooding. So you want to remember that and check the weather before you head out. The distribution of deserts are controlled by a variety of things. We're going to talk about 4 of them in this video. The first one is descending air. So hot air rises and cold air sinks. And deserts that are formed because of this are referred to as climate zone deserts. And they tend to exist in a band from 30 degrees north latitude, so that's this dashed line, to 30 degrees south latitude, that's this dashed line. If you look in this area, you see that there are lots of really large deserts. The Australian one, there's one in South Africa, the Sahara Desert, the Arabian Desert, the deserts that go across Eurasia don't quite make it into our category. That's a different kind of desert. So we'll talk about it, I suppose, too, this morning. It's important to remember where the Gobi Desert is. We'll come back to that. But the deserts in the 30 degrees north to 30 degrees south band are called climate zone deserts. And it's all about the air circulating in what we refer to as Hadley cells. So the air around the equator gets warm and the hot air rises and moves up and away. And then when it circles back down, then it can bring rain with it. So as it's rising, it's taking moisture away. When it comes back down, it's bringing moisture with it. So as I've said, when we looked at the first graphic, most of the Earth's major deserts are located between 30 degrees north latitude and 30 degrees south latitude. So you've got this band. And it's all because as the warm air rises up from the equator, it takes moisture with it. And as it cools, it'll produce rain only when it moves away and outward. So it produces the rain, and then the cool, dry air is going to sink down and absorb, it'll warm up and then absorb more moisture. So it's a cyclic pattern of taking moisture up and away from the equator and bringing it out and not cooling off enough to have rain occur again until it's quite a ways away from that. Another factor is something called the rain shadow effect. If you have a continent with a mountain range along the edge, the mountain range can shield the interior of the continent from rain. And so what happens, we'll take a look at, again, the graphic. So what happens is you have the ocean over here on the left-hand side, and the warm, moist air is going to rise. It'll get higher and cool off, and that makes it rain, because warm clouds can absorb a lot of moisture, but cold clouds cannot hold much. So when a cloud cools off, it rains. We've got rain. But in order to get on the other side of the mountain range, the cloud has to go up so high that it's pretty much always dumped all its range on the ocean side. So any clouds that get to the continent side don't have very much moisture in them. And the result will be that you've got dry air on the continent side. So on the ocean side, it rains. On the continent side, there is no rain. So on the continent side, there's a desert. And the mountain stands in the way. If the mountain were not there, this cloud maybe would have moved inland more before it finally cooled off and rained. But in order to come up and over the mountains, as it goes up in elevation, it cools off, and that's why we end up with the rain on the ocean side. Another reason for a desert is a great distance from the ocean. So in that first graphic, I said, remember where the Gobi Desert is. The Gobi Desert is pretty much in the middle of China, and it is so far from any large body of water that you just don't get rain there. So that desert is because it's such a long way from any large body of water. Another reason for deserts would be cold ocean currents. So again, remember, cold air makes rain and warm air soaks up moisture. So if you have a tropical coast, so the land is warm, next to a cold ocean current, then you're going to end up with a desert. And so what happens is the cold air, as it moves over land, it's going to warm up and it absorbs moisture instead of producing rain. And you can see these currents in the map we have. So the California current is a cold ocean current. Anybody who's tried to go swimming in the Pacific Ocean will tell you that. The Peru current is another cold ocean current. We've got several more listed in the graphic, the West Australian current, and so on. So land masses adjacent to those cold currents are the rain will fall, but it's going to fall over the ocean, not over the land. When the air reaches over the land, it heats up, and instead of making rain, it sucks up moisture. In fact, we have a little drawing to help us with that. So we've got a hot land mass and our cold ocean current. And so any clouds over the water are going to be cold clouds, and they don't hold moisture. You get rain out of them. But as that cloud goes over land, the land will heat it up. And instead of making rain, it'll suck up any moisture from the area than it can. So we need to discuss wind action. So wind is a really important agent of erosion. It differs from water in three main ways. Wind can only erode fine sediment, where water can pick up larger materials and carry them. Wind is not restricted to a channel, so it acts over a really large area, whereas water stays in its riverbanks. Wind is not chemically active, so it's not going to dissolve rocks, whereas water is a really big agent of chemical weathering. It dissolves minerals, it takes things from one location to another. Water does a lot of chemical weathering. So wind acts to remove the smaller particles on the Earth's surface in a process that we call deflation. And it'll even move really larger rocks and leave behind a surface that's really polished. We might think of that as sandblasting. You can go out west and see rocks that have been worn smooth, not by water action, but by sand action. Wind velocity is determined by changes in temperature. When we think of a place that has a prevailing wind, it's almost always because you have two different objects heating up and cooling down at different rates. So the bigger the change in temperature in an area, the stronger the wind is going to be. The desert has really hot days, but very cold nights. And so this difference in daytime to low time temperature creates wind currents. The bigger your difference in temperature, the stronger your winds are going to be. Well, why? Well, we'll look at the graphic in just a second and talk about why. So this graph shows us wind velocity on the horizontal axis and rate of sand movement on the vertical axis. And you can see if you're going 10, 20, 30 kilometers an hour, so roughly 5, 10, 15 miles an hour, the sand doesn't move very fast. But there's a big jump when you go from 40 to 50 to 60. There's a big jump. Dust storms can be very detrimental to a landscape. There was a particular dust storm in 1933 that carried the dust as far as New England and even made the snow in the Midwest and New England towns brown because of it. And you may have noticed in the summer of 2020 in the Hickory area, we had a few days where there was a dust cloud that had come from the Sahara Desert. And if you went outside and looked, it made the sky at the distance look like maybe there was rain. And I know where we lived, I could smell the dirt in the air. And it irritated my nose. And I can't even imagine what it would have been like to have lived in the 30s when dust storms were prevalent across the southwestern United States. All right, so wind blows in a predictable direction. So if we look at this, suppose we're at the beach and the sand is hot and the water is cool. We won't go so far as to call it cold, but it's cool. So hot air rises, so the air over the sand will rise up. This is during the daytime. Here's my little son. And if the water is cool, the air over the water is going to sink down. So during the daytime, the wind is going to blow from the water towards the land. But if you go to nighttime and the air cools off, the sand is not hot anymore. So the sand is cool. That means cold air is going to sink, but the water is warmer than the sand. So the warm air over the water is going to rise up and you get wind blowing from the land towards the water. So during the day, the wind blows from the water towards the land, and at night it flips directions. If you've ever done any sailing, especially in the coast, you maybe have noticed that if you sail early in the morning or late in the day, that the wind will shift directions. So most cities are not really windy. I know if we walked in downtown Hickory, most days you wouldn't say, oh, Hickory's windy. But some are called windy. Chicago is called the Windy City. And the reason is because it has two things that heat up and cool down at very different rates. The lake heats up very slowly and cools down very slowly, whereas the buildings and the streets heat up quickly and cool down quickly. And so the difference in the two temperatures is going to produce wind. You see prevailing winds at the beach because the sand and the water heat up and cool down at different rates. You see it in some cities because the lake and the buildings heat up and cool down at different rates. In Hickory, there'll be days in the spring and days in the fall where our weather's going to change. You'll have a front coming in. You might have one day where it's 75, 80 degrees, and the next day it's 50. And usually if you have those kinds of changes in temperature, you're going to have a windy day. I think that stops, so we will stop the chapter.